All right, we've got standard error of the mean and level of confidence on this one. So, to be able to find the standard error of the mean to predict the true mean of the population with a certain level of confidence. All right, here is your normal curve. Remember, we've got 68.3% of the data is between -1 and 1 of your standard deviation, one standard deviation of the mean. 95.4 is within 2 standard deviations of the mean, and 99.7 is within 3 standard deviations of the mean. So, a test has a mean of 80 and a standard deviation of 5. Write the interval where 68.3% of the data lies. Remember, this is one standard deviation. So if you are at 80 and you're going over one standard deviation from each, that would be 85 in this direction and 75 in this. So it lies between 75 and 85. Okay? 95.5% of the data is 2 standard deviations. Okay, which would be 2 times 5 or 10 that we're adding here, or just another 5 to the 85. That would be 90 and 70. So it opens up the interval, goes from 70 to 90, and that's 95.5% of the data. The last one, 99.7, is 3 standard deviations. Okay. And that is 3 times 5 is 15 that you're adding and subtracting from 80, or just one more 5. So that actually goes from 65 to 95. So that's why it has that much more of the data covered. Okay. Vocabulary. So this is something that you need to get down and write it down in your notes. The population, the entire set of items or individuals in the group being considered. Random sample, a selection so that it is representative of the entire population. Inferential statistics, inferences made about the general population using the characteristics of the random sample of the population. Sample mean, that's that mu, the mean of the random sample of the population. Standard error of the mean is right there, and that's your mean. It's the standard deviation of the distribution of the sample means. Confidence interval, the boundaries on the left and right of the mean that define a certain level of confidence, 95% or 99%, that the true mean is in that interval. Error bound for a population mean is a value used when the standard deviation is not known that is added to and subtracted from the sample mean, an estimate for the true mean mu. Okay? So, to construct a confidence interval, we need mean, the x, as an estimate for mu, the unknown population mean, and we need the margin of error. The confidence interval estimate will have the form, this is in interval form notation, that mean minus the error bound of the mean, that's down here, it's on this end, and then the x, the mean, plus that error bound of the mean, which is going to be on this end, to the right. Okay? Suppose we have data from a sample. The sample mean is 15, and the error bound for the mean is 3.2. What is the confidence interval estimate for the population mean? Okay, so what you've got here is exactly what you're doing here. The sample mean is 15 and the error bound for the mean is 3.2. So what is the confidence interval estimate? You would have 15 minus 3.2 on this end, and 15 plus 3.2 on that end, which would give you a 0.8. 10 minus 2 is that. 4 minus 3 is 1, so you have 11.8, and this would be 18.2. All right, now, depending on what confidence level you're given, you would say if you had a 90%, or just like on our example, if you had a 95% confidence level, then you'd say, I have 95% level of confidence that the true mean of the population is between 11.8 and 18.2. All right, suppose we have collected data from a sample. We know that the sample mean, but we do not know the mean for the entire population. The confidence level is 95%. Okay, so the same thing is going to happen that happened before. You've got 7, so we'll do exactly what we just did. We have 7 minus 2.5 and 7 plus 2.5. So this right here would give you 4.5, going from 4.5 to 9.5. Confidence level is 95%. You can say with 95% certainty that the true mean of the population is between 4.5 and 9.5. Okay? When you find the mean of the sample, it's only an estimate of the mean of the population. So the standard error of the mean is like the standard deviation of the normal curve. So recall roughly 68% of the data falls within one standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean, and 99% of the data falls within 3 standard deviations of the mean. Okay. If a sample of data has n values, and that is the standard deviation, the standard error of the mean is the standard deviation over the square root of the number of values that you have. So, if the standard error of the mean is small, then the sample means are closer to the true mean. If the standard error of the mean is large, many of the sample means would be far from the true mean. The greater number of items or subjects in the sample, the closer the sample mean reflects the true mean, and the smaller the standard error of the mean. So, back here, what is the standard error of the mean? Remember, it had a standard deviation of 1410 right there, and the number of values that she was getting was 100. So when you substitute that in, you have 1410 divided by the square root of 100, which is 1410 divided by 10, or 141. So, that is your standard error of the mean. Okay? Again, we've got your confidence intervals again, found using the same information from the normal curve, except what we will multiply by are these multipliers. For a 90% confidence level, the multiplier is 1.645. And your error bound in the mean is the multiplier times that standard error of the mean. Okay? So, for instance, 90%, 1.645. Your error bound for the mean here would be equal to, for your 90% confidence level, 1.645 times 141. That's how you would find what you would add and subtract. Okay? The multiplier times that standard error of the mean. If you were doing 95%, that was where you had a multiplier of 2. So you would do 2 times that 141. Then 99% was 3 times that. Okay? This is really the only new one, because you've got that 95% was 2. You can see the multiplier there. And the 99% was 3. You can see the multiplier there. So the 90% one would be the only one that you really have to pay attention to. We're headed into 10 minutes now, so I'm going to stop and we'll pick it up on the next one.